I'd like to jump right in with a question we asked ourselves when we started some time ago, and we asked ourselves, how would we or how would you like to build confidential computing applications? And our approach to this question was that confidential computing is a cloud technology, so let's take a look how cloud applications are built today. And what we find, and what probably you will find, there's a large community called the cloud native space, and they've built this vast ecosystem of open source tool stacks. And what people do is they take those tools, those DevOps development tools, and they build their application in a microservice architecture. So you separate your concerns, your business logic into separate parts that you can then scale up individually. You can exchange the individual parts, and it's a great, it forms great for an agile development lifecycle. And we thought, well, this sounds pretty cool. We want to build confidential computing applications just like that, right? We want to have the same kind of approach to it. And we also thought that, well, if this is the thing people do today, and if we want to have the cloud native community on board and adopt our technology and make the cloud a more secure space, we need to bring our technology on this level, so they don't have to adjust much. For them, it's as easy as possible, as convenient as possible, and they just have this confidential computing tool stack they can use similar to their tool stack. And then what we essentially ended up with now is two tools. We have a tool to build confidential microservices, and then we have a tool to do all the DevOps of deploying microservices to your cloud and administrating all those microservices running there. And I want to start with how we build, or how we imagine people building confidential cloud apps, and build them with Go. And this is called eGo. And I'd like to take one step back and answer the question, why did we choose Go? I think the most obvious one is, of course, that most cloud native tools are written in Go. There are several reasons why people there love the Go language. It's super simple to learn. It's very efficient to write your code in Go. You can do a lot in very short time, and it's built for all those parallel tasks, and just seems to be a great fit. And also the same reasoning here, since most tools are written in Go already. If we support Go, the likelihood that people will jump on our train and start to use confidential technology is very high if we support Go. And if you've never seen Go, it's really built for simplicity. It's very readable code, and also the whole build process, the whole tool chain is very straightforward and easy. So you see, we have two essential commands. If you build your Go code, and then you can run. You can also run your Go code, which is then a compiled binary. And what we did is we built a runtime for Go that runs inside an enclave, and that works great, right? So now we have Go code that potentially can run inside an enclave. But what we then had was this very tedious process of taking this specific compiled Go binary and build the enclave around it and package this into a container. And this was the tedious process, and it didn't feel right. It didn't feel cloud native. So this is when we come up with eGo. So if I switch slides, you see the same process, but now with eGo, and we don't just build a Go binary, we build a whole enclave. We added one command in between the build and run, which is sign, and this takes your compiled Go binary and packages this inside an enclave. And then eGo run will run this enclave. And you might say, okay, well, this is easy. This is pretty straightforward for a hello world. So let me show you how this looks like if you have a more mature project as HashiCorp Vault. Some people might know this. This is a very popular secret store in the cloud native space. And you see we have this ego env make, which basically wraps the build process and injects ego at the right spots. And then we have to do one additional command, again, the sign command. And then we have the Vault server running inside an enclave and ready to be deployed in the cloud. And it's really that simple. And I don't want to add much more here, because I think this showcases really much what we try to tell you, that this is very simple, and it's not this is very close to a regular Go development process. So to summarize, what does Ego get you? You get secure enclaves. They're very straightforward to use. It's super convenient. The enclave that pops out of this is lightweight. It's just your application code, some Go runtime, and a small compatibility layer for the confidential computing technology. And we built this on top of Open Enclave. So it's built on established standards, and we don't have to take care of all this low-level stuff. Open Enclave does for us, so we support the latest Sdks, for example. And those things that you build there, they run potentially everywhere, right? You can run the binary itself. You can run it in simulation mode. That's something specific to Open Enclave, and then you can also run the full enclave. And this allows you to have the same build process, same debug process as you would normally do with Go. And also when we when we build those microservices in Go, now it's very easy to bring them to the cloud, to scale things up. And this is what the next step I'd like to show you is what does it mean to scale up things in a confidential context. Because the next tool we developed was Marblerun, which we like to call the service mesh for confidential computing. And again, I like to go one step back and explain the process that leads us here, and explain a bit the problems to really understand why we ended up with Marblerun. So when we started to deploy Go microservices that run inside enclaves to the cloud, there came a bunch of challenges that we like to solve. The first thing was that, okay, now we have this microservice architecture where each service runs inside an enclave, but from the outside world, I normally don't care what architecture this is, if this is microservices or just one big blob. So the user somehow just wants one attestation of the whole cluster. The user doesn't want to interact with each service and do attestation with each service individually. Especially if you scale things up, this is not practical. You want one concise statement. Second thing is if you have your services separate in pods, and so pod is the abstraction in Kubernetes, and you have one service or one pod wants to communicate with another and wants to share data. How does the one pod know that the other is actually running inside an enclave and it's safe to share the data? Next thing we noticed is, okay, if you want to distribute secrets, you normally take, for example, you have a web front end and you want the same certificate used by all those instances. How can we distribute the certificate? And keep in mind that if the certificate leaves the enclave boundaries, so certificate is on the host or unencrypted on the network or anything, it's not, it hurts the confidential aspects, and it's not considered confidential anymore. So we need to somehow distribute secrets in a confidential way. And one thing that really where we shot ourselves in the foot was sealing. So we deployed a confidential app in the cloud, and it got rescheduled. So it was shut down on one node and restarted on another node. And in Sdks, sealing keys, so the keys you use to store data persist on a disk, are bound to the CPU. So each CPU has a different sealing key. So it was sealed with one key on the first node, and then the application tried to unseal it on the second node, and this failed because the key changed. So how can we make sure this is somehow abstracted and we have some kind of virtual sealing keys that you can unseal your data wherever you run and you're not bound to one node? And we also always want our connections to be terminated inside enclaves, so you never have any connection that transfers data in plane outside the enclaves. And the last point I like to make here is, so how do we update code, right? So new version of our Enclave code, and how do we ship it, and on all the pods and the outside world is aware of this and is fine with this, or can make or can at least recognize this through a remote attestation. All right, so from a general perspective, what we thought was that right now each pod, each enclave has this traits of being always encrypted, being able to attest or produce a remote attestation statement to the outside world. But in a cluster, I want to bring all those traits, and I want to have them for the whole cluster, not just for the individual pods. So what Marblerun tries to do is basically give you that. It tries to bring this abstraction to your whole cluster. And with that, we want to have end-to-end confidentiality, integrity, verifiability of this cluster, not just the individual services. And as some additional features, we want to be cloud native, of course, and be updatable, so all parts can be updated. If you're familiar with service meshes, you might ask yourself, okay, so existing service meshes already solve some of these problems? And I'd like to stress the point that this is not the case, because normally a service mesh considers the host, or at least the host machine, as a trusted party. So they terminate the TLS communication in a separate container, typically called a sidecar, and then forward the traffic unencrypted through the host into the other container that's then processed, which is not okay if we, or at least it hurts the confidentiality in our case. And also secrets are distributed and end up in a non-enclave world while doing so. And of course, also they don't have any awareness of Sdks and have no remote attestation or anything that they would do. But we don't want to reinvent the wheel, right? We want to augment these existing services. So we want to keep their cool features. You should deploy your favorite service mesh, and they will do all they are very good at. And then you just add Marblerun to help you with all those problems and challenges I just described. And together they form the super nice confidential mesh or confidential service mesh. So let's take a brief look at what this looks like. Imagine you have a bunch of services in a microservice architecture. You wrote, each of them is running inside an enclave. So the first thing we need to do is we need to inject a small piece of code inside this enclave, which is typically referred to as the data plane layer or the service mesh layer that does all those handling of the task a service mesh needs to do. So we have this data plane. And then on top of that, we added an additional service, which is typically referred to as the control plane. So the control plane takes care of orchestrating all those services and implementing all those features to the challenges I showed you. And it's also important that the service mesh tries to move the solutions for these challenges to a separate layer, so you don't have to implement them in your application yourselves all the time. You just add the Marblerun service mesh and don't have to worry much about the CC. So let's take a look of what a typical workflow would be for a DevOps engineer after they've deployed this scenario, this microservice, and the Marblerun service mesh. They would post something, what we call the manifest, that more or less defines how your confidential mesh should look like, what services should be part of it, and so forth. And then the control plane would take care of adding services to the mesh according to this manifest, authenticating them through a remote attestation procedure, and then provisioning them with their secrets and their certificates and authentication methods. And now we have this mesh, they're all connected, they can communicate to each other and always be certain that each one is running inside a secure enclave. And from the outside world, we also use the control plane to get one concise remote attestation statement, a root certificate that spans over the whole cluster, and you can authenticate each service. And you can obtain the manifest to check what was deployed there. So to summarize the benefits here, the DevOps engineer doesn't really need to know or very much about CC, right? They can use whatever tooling they already had. They can scale as normal. They can update code. They also don't need to change the application code that much. They just need to inject this small data plane code to the application. And from the user perspective, it's even better. You can do in one step. You can verify that everything runs in Enclave. Everything is always encrypted. You can verify the topology of your mesh, and you can verify what kind of services are running there, so more or less the identity of your cluster. So from a user perspective, it's even better. So let's take a brief look in the marbles. Well, this is what I forgot to mention. This is what we call the data plane. So each service we call a marble. And currently we support, of course, the Ego runtime has native support, or the Ego tool. This Ego is based on our runtime, so we also support C++ there if you would like to develop your microservice in C++. And we support currently two libOSs, Graphene and Oclum. You already heard from Hong Liang to talk about Oclum, and I think right after my talk, Mona presents Graphene. So if you're interested in library access and the lift and shift, definitely check them out. And we also support them. And this also means your mesh can be diverse. There can be an Ego service running. There can be a Graphene and an Oclum running in the same mesh. And the control plane takes care of managing this. Quick summary, what does Marblerun get you? Everything is end-to-end encrypted, end-to-end verifiable over the whole cluster. You don't have to worry about the individual services from the outside. It's compatible with all your tools, Kubernetes, Helm, your regular service meshes as Istio, Linkerd, and so forth. So your typical cloud native tool stack, to summarize, right? And then it's also built on Open Enclave, so it's built on the same standards as Ego. It gets you very fast and easy deployments, so DevOps is key here. And we're cloud agnostic, so technically, if your cloud provider supports confidential technology, Marblerun should also run there and just work. And now I'd like to give you a short demo of how this could look like. So we took the emoji Voto demo service. This was built by the folks at Bouillon, who are behind the Linkerd service mesh. And they build a very simple microservice that consists of a web front end and two backend services, one more or less implementing the application business logic, and one contains the state. And they all communicate with each other through plain gRPC, no encryption or nothing. They don't run in an Enclave or anything. So what we did is we lifted them to run inside an Enclave using Ego. And then we wanted to have the connections between the services encrypted. We had to do a slight code modification here. The Ego API provides you with a function that gives you a TLS configuration and credentials. And then we use those credentials in all those gRPC server and client calls. In the future, we like to reduce this to 0 code changes. We're actively working on mutual TLS, so you don't have to change anything. You just deploy it and say, I want to have mutual TLS between those services, and you're good, like your regular service meshes do, but we terminate the connection inside the Enclave. So this is even better. All right. I hope that Felix has posted the link in the chat for the demo.
It's there.
It's already there.
Yes,
so you should be able to connect to this. I mean, you probably noticed that we love emojis, so you can go there vote for your favorite emoji. I can show you a bit what happens on the back end. We have deployed this alongside with Marblerun alongside Linkerd. You should hopefully be able to see my Linkerd dashboard. You see there's 3 services running, the web front end and the 2 backend services. I can open Grafana and have some insight into the traffic. Of course, Linkerd doesn't have the same insights as I normally do because I can't intercept our TLS connections. But to show you how easy it is to work with this, I can do a typical procedure of scaling things up. So I might scale up the web services to 2 instances, and also the emoji service. There we go. And then if I go back here, I should see there's a second service started for the emoji and a second for the web front end, and they're all authenticated by Marblerun, then added to the mesh, and then the existing mesh starts to communicate with them as well. All right, play a bit with the demo and vote for your emoji. I hope I could. You got a good impression of our tool stack there. I think the key takeaways is we try to make it as simple as possible, as cloud native as possible. So it's super easy to use. People are willing to adopt and try out confidential technology to make their applications more secure and keep data private. You can find the projects online. We also have GitHub repos with the source code. Check them out. Leave a GitHub star. And if you'd like to chat and get involved beyond the OC3, we have a GitHub chat. You will also find this in our repos where you can contact us. That would be it for the presentation, and I think we have a little bit of time left for the Q&A.
Yes, thank you so much, Moritz. And you mentioned the GitHub stars, and I think we have seen a lot of great projects who are on GitHub, and I learned that stars are very important currency there. So if you find some projects you like here on OC3, feel free, go to GitHub and leave some stars. People would be happy about it.
Exactly. We love GitHub stars.
Felix, we have some questions, right?
Yes. So first question from Tiziano. Is the app supposed to return a remote attestation report for some endpoint?
No, the app itself not. What we do, or what we imagine how things work, is that you would get the remote attestation statement from our control plane. For the sake of the demo, we haven't exposed the control plane, just to keep things simple there. And there you would get your remote attestation statement. You can verify. You also get the manifest. You can verify, and then you get a certificate and use this certificate to authenticate the front end service. Yeah.
Right. So in the demo, maybe I can share the demo, or maybe not. So in the demo, essentially, you connect over a self-signed TLS certificate, right? And then you can get a remote attestation statement from the cluster for. There's a demo app, yeah, for the TLS
right
certificate. Yeah, and there's a question from Anyo. What's your opinion? Is there a path towards making existing service meshes confidential compute aware? Is there any benefit over Marblerun, which replicates some security functionality, to move it into the Enclave?
Okay, so it seems to be 2 parts. First of all, making existing service meshes confidential computing ready. I think technically you could, right? So what they do is they use a separate container with the sidecar, and there's running a proxy, which you could maybe move inside to the Enclave and then work from there. But I think the cloud native thought is more or less keeping things simple and do the things you do well and focus on them. And then you add another service, in this case Marblerun, that is very good at the confidential part, and you join them together. So yeah, and the other question was, what was the other question?
The second part of the question was, is there any benefit over Marblerun, which replicates some security functionality, to move into the Enclave? Not sure. Maybe there's a typo. Maybe I can skip to that question.
Yeah, I think there would be. I think it would be quite the opposite to move. So if I understand the question correctly, I think it would be quite the contrary if so you would not have security benefits of moving existing service meshes inside the Enclave. They typically run the Envoy proxy written in C++, so it's introducing more potentially vulnerable code to the Enclave. And Marblerun is pretty lightweight, pretty little data plane code. So I don't think this, yeah, this would help.
Yeah. I mean, maybe that approach is more suited for the confidential VM approach, where you take your VM, your entire pod, and in that case, you probably just want to have your Envoy proxy inside that VM as well. Yeah. Another question regarding Ego. In Ego, do syscalls, e.g. reading, writing to files, always exit the Enclave, or is there a way to trap or emulate them within the Enclave?
So the syscalls would be implemented by Open Enclave. I'm currently not sure if I can answer the question. Maybe we can do this in the breakout session. I'm pretty sure Thomas knows more.
Yeah. Maybe so maybe I can add that Ego has a virtual internal to the Enclave file system. So you, you can trap, you can redirect certain paths to stay within the Enclave and not go to the untrusted operating system. And this helps with some applications.
Yes.
Okay. Do we have more questions, Felix?
We have. Let me check. Maybe we have time for another one.
Yes, I think we have.
What does a remote attestation of the entire cluster look like to a client, and is it possible to reuse the CA approach with other Enclave SDKs?
The remote attestation statement is a quote obtained by our control plane, containing the certificate of the control plane, and basically in combination with the manifest gives you the whole picture of the cluster, and compatible with other CC technologies. So I guess other than Sdks. So far, as of, I think, Open Enclave doesn't support AMD SEV, for example, but as soon as they do, we can definitely also support them. Considering the marbles, we are not bound on Open Enclave, right? We would also support Graphene, Oclum, and potentially AMD SEV, though it's not implemented yet for AMD SEV, for example.
Okay, thank you so much, Moritz. Thank you, Felix, for collecting the questions. And Moritz, you will be in a breakout session in about half an hour, I think. So from 7:30 p.m. CET means 10:30 a.m. PST. People can talk to you in a breakout session about Ego and Marblerun, right?
Right, perfect. Yeah.
Okay,
Thank you very much.
Thank you.
Bye-bye.
Bye.